Okay, hope all of you can hear me. And previously we discussed these kind of keys, right? Hope all of you can understand. And we mentioned about so that is discussed under differential integrity and different keys like secondary, composite, candidate kind of keys. So then integrity rules, and the importance of data integrity, very important. We already mentioned that. And here there are different integrity types. So requirement, entity integrity, right? Then what is the requirement? All entries are unique and no part of primary key may be null. So that is the requirement. So then you can understand the purpose also. To uniquely identify scenario, you can understand why entity integrity is important. Then next type of integrity we mentioned, referential integrity. So requirement is this. We already know now these terms and the way that how they are working. Okay. So referential integrity makes possible for an attribute not to have a corresponding value, but will impossible to have an invalid entry. So what are then next implementation referential integrity may rule make it possible to delete a row in one table whose primary key has mandatory matching foreign key value in another table. So this is the example. Okay, then previous things are related to theory. Okay, we will see that how we can practically do that. The customer might not yet assign a representative, but it will be impossible to have an invalid sales representative number. Here, table about this first table is about customer table. So database is this one, and that database has the okay, we can see two tables of that database: customer table, primary key, customer code, foreign key, agent code. Here, table, agent table, primary key, agent code, no foreign keys. Understood? Then this one foreign key is agent code. Okay, here you can see some null entry there. So if this person is not belong to not comes under this agent, or he doesn't, if this none of these three people are not agents of this person, so we can't mention any foreign key there. So that kind of scenario we can keep in blank, no problem. Okay, read these things and understand these concepts. Okay, I will give 1-2 minutes for understand these concepts properly because of this is important. Hope all of you can understand. Reason kept this as null, this data here. Okay, then next one. So these concepts are regarding to entity integrity and referential integrity, entity integrity related with the primary key. Okay, then referential integrity that is related with foreign key, and we mentioned reasons for and requirements regarding to these two types of integrities. Okay, then read these things. So you can understand the importance of having these kind of rules. Then avoid nulls. Some designers use special codes unknown as flags. So sometimes some systems are not allowed to enter keep that data as null values. Null values means what? There are no any values there. Got that? To avoid that, we have to enter some value. So that kind of sample values are called as flags, right? And persons who are inserting data into tables, they can use flags when agent codes are. So that means foreign keys are not aware, or they don't know when they don't know. But can they keep this primary key null, or can they keep some flag value? No, it is impossible. Then entity integrity and referential integrity behaves in different ways. Hope you can understand now the difference of them. So dummy variable value used as a flag, and it can redirect or what linked with that value, this kind of dummy values. So the same explanation goes here. The method of referential integrity and entity integrity වැඩ කරන්නේ කොහොමද කියලා ඔයාලට අවබෝධයක් එන්න ඇති. එතකොට මේ integrity විවිධ integrity පාවිච්චි කරන්නේ දැන් types පාවිච්චි කරන්නේ මොකද මේ rules පාවිච්චි කරන්නේ. හරි. consistency එක database එකේ වැඩි කරගන්න. එහෙම වුණාම තමයි your relationships හරියට වැඩ කරන්නේ. එතකොට දෙන අපිට ලේසියෙන්ම queries කරන්න පුළුවන්. accurate results අපිට ගන්න පුළුවන්. මේ database එකේ තියෙන tables අතර සම්බන්ධය හරියට අපිට set කරාමනේ table ටිකක් විතරක් තිබ්බා කියලා connections හරියට එන්නේ නැහැ නේ. relations අපි හරියට නිකන් හැදෙන්නෙත් නැහැ. keys use කරලා build up කරන්න ඕන. ඒකෙදි වැදගත් වෙන rules තමයි අපි මෙතනදී කතා කරේ. එතකොට referential integrity එක foreign key සම්බන්ධයෙන්ුත් primary key මොකද්ද integrity rule එක primary key සම්බන්ධයෙන්ුත් relate වෙන්න තමයි කතා කරන්නේ. foreign key කියලා කියන්නේ අපි දන්නවා tables දෙකක එක table එකක තියෙන primary key එකක් අනිත් table එකේ වෙනත් field එකක් විදිහට තියෙන එක. හරි වෙනත් field එකේ තියෙන අවස්ථාව තමයි foreign key එක. හරිනේ. Okay. Then we can go to our next presentation. We have covered this 14th one, right? Yeah, then 15th one. Relational algebra. Okay, this is not a complex section. Okay, then so this is conditions or math related section. Relational database operators are these things. Select, project, join, intersect, union, differences, reduct, divide, some of them. Relational operators that can be used for manipulate these things. Okay. Okay, then relational database operators, we mentioned about these operators. Then we have to discuss them one by one. Actually, these things are applied for SQL commands mainly. Structured query language, we will discuss that part later. But when you are going through this SQL, then you should know about these operators. That's why we discuss these things first. So you can see the differences. So these are considered as functions. Normally these functions are available all most of times. Okay, then union operator combines all rows of two tables. You can use union operator for what? Combine all rows of two given tables. So the next one, you can see that tables, two types of table, and after that, this table union left table union right side table can produce a final output. Then it can what? Join. So the term is union, right? Okay. Make you can collect all the rods into one table by using join function, also called as join operator. So next one, insert operator. Produce listing that contains only the rows that appear both tables. Right? Then the two tables must be union compatible. Previously, we learned about data types, numerical data values. Okay, text data values like characters. Here, so intersect operator. So after intersecting, so what are the common things? Jane and George are the common fields for both. Then the output becomes this A table intersect B table, if these things considered as A and B. Then finally output C is equal to this one, right? So that is the difference. So that is the way that intersect operator working. So these are not a complex sections. Okay, difference operator. So only the different things, that common things are not displaying as the output. Okay, as a result, and different things each other can be displayed as the output. Okay, that different value can be located in a left side table or may can be contained in right side table, any of one. Anyway, finally it becomes result. Product operator, it is different. No need to become a union compatible. So if one row has one table has 10 rows, other table has 20 rows, it composes 10 into 20 rows, 200 rows. That means, yeah, look at this example, flashlight, right? These three needed to be added for flashlight. Look at this one, flashlight, this one, and this one, three values. So one like that way, lamp again 3 rows like this way. So that way, here 1, 2, 3, 4, 5, 6. 1, 2, 3, 6 times 3, 18 records would be displayed completely to intersecting these two tables. Then select operator, read and understand these concepts. Select operator, read and understand these things. Okay, here you can see select operator, the way that select operator working. So select all will lead this way, then select only price less than 2 yields this one. Then you can see these, the way these commands can be handled. Select p card is equal to 31145 to yield that yields. Then in SQL we are writing these kind of commands by using standard language rules according to SQL, structured query language. Then by if there is a database and tables and relations, according to the given command, the only thing required thing can be displayed. Right? So that's the way this select operator working. Then project operator, look at this one. Okay, you can see here project operator, then vertical subsets, right, can be produced by using project operator. Project price, okay, by using field names, right? Project descriptor and price. So just ask to project the required fields according to the situation and the requirement. Join operator, same kind of simple concepts, but so joins are too many types: natural join, left outer join, right outer join, theta, and kind of joins are there here. So this is the way that natural join works. So customer and table agents can be found there. When you need to join these tables, what would be the thing you have to do? So you have to follow some steps to join them while you are trying to join them. So the first one, product of the table is created. After that, select is performed, step 1 as the output. After that, project. Hope you can remember the previous operator you learned. Because that what is the product of two tables mean this when this product multiply kind of thing, right? After that, select performed on step 1. Then you can forward to yield only the required to get required rows. Only the equal values are having. After that, you can perform project operator for step 2 results. You have to use project 1 to get a single copy of each attribute. Then all other things like we learned in project select, okay, and product has to be applied there. So this is the way that outputs are displayed. Product after producting product, these two tables making product in between these two that look like this way, right? Select after performing select that should be look like this way. After that, finally, performing project can avoid duplicates, right? Like when there are duplicates like these things, then you can remove that by using product operator. So these kind of operators can be used for manage your tables in databases. So divide operator is the next and last one according to our syllabus. So table 1A or table B or two tables can be used, then divider, and then you can divide this table by this one, smaller one, then what would be the answer you will get? So divider required use of one signal column table and two column table. You can see what is having a one single column and what is having a two columns. So to be included in result, value in non-shared column must be associated with every value in dividing table. Look at this one, right? So A and B can be found 5 times there. Here 3 A's and 2 B's are there. Then so that is displayed as answer as this way. Here the logic. Both tables have the attribute code and LOC code. LOC is not shared, right? And value in what? LOC must associated with every value in the dividing table. And the only value with both A and B is value what? B is what? 5. A and B. Associated only value is 5. That's why 5 representing as the result. Okay, then we can go to next lesson. So that is again regarding to a relational database model. Okay, previously we learned about ER diagram. So that is the final thing. When you know about the all you learn, then you can map ER diagrams properly. Then here we are discussing about how to produce relational schema or relational diagram. Or relations means you know that what is relationship. But here we have to emphasize how relations are relationships are occurring some specific selected database or section. So that's why we are going to, we are studying this section. Okay. Look at these things, first understand these properties of these tables, then we can discuss the theories regarding to these sections. Okay, now two tables can be find here, and these two are having different fields, and these two tables has a relationship, and foreign key is the agent key, agent code is the foreign key. Then there is a thing it mentioned here, has been mentioned here. So when it is having a connection in between records, we can go through these. So here, so this person Zoisa Uday Soisa, agent cause is 502, and his agent 502, and Ravi Alvis, and agent phone number can be find here. So that's the way they are the information we can retrieve by going through these tables. Then, like in that way, we can access required data. So that is the thing it is explaining here, right? And there may be one-to-one, one-to-many, and many-to-many relationships. Why? Here, okay, then these things we already know. Okay, after that, we have to learn about relational schema. And one-to-one, one-to-many, many-to-many relationship types. Then previously we talked about Udesoisa. If that person work as one entity, that one entity has how many connections? Right? One. But Ravi Alvis is the agent. Okay, Ravi Alvis behave as the agent in how many records? Okay, 1, 2, 3, 4, one to many relationship type. So that's the way you can determine relationship type by going through these data. So these relationships are occurring related to this foreign key. What? Foreign key. So without having a foreign key, we can't tell about a relationship or type, or where you should have a relationship first, right? Then only we can say relationship type. So that is the way then different software or framework displaying these things by using different notations. Okay, this is a very basic way that the relationship types are displaying. So very basic and common way, right? So one agent, previously I mentioned the same example. So one agent may have, right, can have multiple customers. So one can be that this software, the given example software or framework use one as one, but for many it is using this notation as if. Then you can understand, okay, one record can have connected with multiple records of this table. This table means customer table, and this table means agent. That is what we gone through in this example. So relationships within relational database, you know now these things. Already know. Previously I told that when you are learning these things at the very first times, okay, these things will be repetitively comes. Yes, okay, it happens. One to one, an example. So this is a different example, right? Dean and faculty. So you can see there in this example, one to one dean, one dean for one faculty. So one faculty has only one dean. One faculty can't be have multiple deans. So okay, one dean can't be normally appeared as deans of multiple faculties. So very important to understand these things. Okay, you can go through these examples. Suppose and it's in these things and same kind of examples are helping us to understand the concepts in a better way. Okay, then so one-to-many relationship types, and so previously we mentioned these things, right? The entities, relationships, and the relationship type can be found here. Here for one, it is only mentioning here one painter, multiple paintings, right? Here then that can be that so you know that these entities can be represented using tables, and relationships can be displayed like by using these kind of lines, and relationship type. Okay, relationship and relationship type is different, right? And relationship types can be seen as this way, right? Then here to here relationship, and the type is one to many, maybe two or more than two there. Should be and must be actually, right? Here, one relation there. So one painter can be uniquely identified using painter number. And here, right? 1, 2, 3. He has involved to drawing 3 paintings. Each painting can be uniquely identified by using painting number. Got that? Painting number. Then, okay, read and understand these concepts clearly. Take some time and read and understand. Okay, then, so we now you may have a good knowledge regarding the relationship and relationship type, then how the way that it is representing. Okay, okay, these are just facts, right? Still, this is not a relational schema. Okay, this knowledge would be important for understand the upcoming concept. So go through these texts and understand these examples. Paint examples you already know now, right? So other examples. Okay, then next example have been used in class and course. Okay, one course can have multiple classes. So that is the example. So an accounting 2 course might have 3 classes offered on Monday, Wednesday, and Friday. Then there are the things you can understand, right? Then after that, you can see these information, read and understand these information. Okay, see here, the same kind of the one-to-many. Hope you can understand one-to-many relationship here. And here table course has the primary key course code, and table class has a primary key as a class code. Then they have a relationship. Okay, this course code is working as the foreign key for this table, right? This table or this works as the foreign key, and course code table it works as the primary key. So then we can understand this concept by going through the tables, given examples. Hope all if you can understand these things. And the next example, many to many relationships. So this kind of example. So relationship types we are trying to study and learn in detailed way here, right? So we have gone through one to one, one to many, and finally we have come to this place, many to many. And so the tables are look like this way. So according to the given examples, this Fernando has selected classes, these things, and Lienage. After that, student name, the database name. So here student table, right? Yes, Fernando and Lienage's records are can be seen here, right? Then this one class code and kind of information can be seen. So that seems like the class table. Yes, and relationship has been built using a foreign key, that is the class code, right? Class code is a command here. This is working as foreign key here, and this is working as the primary key here. So then you can try to understand uh, the relationship type. We mentioned that it has many to many. Try to understand that. How and why many to many type of relationship has been seen there. Look at here. This Fernando's primary key, the 452 something, can be found in these kind of three places, right? One too many, right? Then considering another one, this class code, that was this one. Here, other side also one too many are working, right? Then that's why we consider this is as many to many relationship. So here we are discussing about student and course tables or class tables and the relationship type. Okay, then we learned advanced way of representing many to many relationships. Then a composite entity relationship, then composite entity. By using composite entities, you can represent the same thing in an efficient way, right? So here, this is the way you can linking two tables. Student name there, no redundancies, no repetitions, and here this table enrollment or enrolled table. After that, class or course table, right? Look at the fields which are including in this enrollment table. Class code there, student number, class code came from where? Class code came from primary key of class table. Student number came from student table, right? Then enrollment grade for your actually it is containing in this enrollment table. So that's the way you can now build relationship using composite entity, and that works as efficient way when you compare the same thing, same scenario with the previous. So the description can be found here. So you have to go through them and try to understand the same thing what I have explained. Then expanding entity relationship model. Expanding. So here diagram, right? And with using composite entity, and entities are there, and relationships also there in between class and the course. So relationship type can be easily found there using this notation. At the exam also, while you are trying to draw these kind of ER diagrams, format should be same like this. Got that? If there are, okay, you have to be careful whether there is or are composite entities or attributes, whether there are attributes for relationship. You already know that there are attributes in most of times in entities, but careful. Sometimes there are some attributes in relationships. So sometimes there are composite entities. Okay, very important to care about that kind of facts while you are reading some context or some scenario or case at your exams, in your exams. So again, relate the way that it can be represented in different software. So database software can be represent these relationships one to many, student and enrolled one to many. After that, class and enroll, we can be found one to many. Got that? Hope you can understand. Okay, then why many to many can't be represent this kind of scenario and how these kind of things are efficiently working. These kind of things means composite entity related display. After that, this calls here one to many, right? So this is one example. Relational schema can be displayed like this way. So that is the thing regarding to this presentation. Okay, this is a single explanation for the given presentation. අපි කතා කරා වගේ කෙලින්ම මෙතන මේ relations tables අතර relationships තියෙනවා. relationship types උත් ඔයගොල්ලෝ දන්නවා. ඒ types දැන් මෙතන වෙනස් software use කරලා ඒගොල්ලන්ගේ තියෙන relationships display කරන්න graphically in detail way අපිට display කරගන්න ඕනනේ. ඒකට මොනවා හරි standard ක්‍රමයක් use කරන්න වෙනවා. ඒ use කරන්න වෙන standard ක්‍රමය ගැන තමයි මෙතනදී අපි කතා කරේ. එතකොට මේ ස්ටෑන්ඩඩ් ක්‍රමේ මොනවද තිබුණේ? ඒ notations තිබුණා. හැබැයි දැන් මේකෙදී ඔය many to many relationship display කරනවට වැඩිය standard technology එක method එක relational databases වල මේ වගේ ඒ වගේ many to many තියෙන apply වෙන අවස්ථාවල අපි කිව්වා use කරනවා කියලා composite entity එක. ඒ වගේ දේවල් එක්සෑම් එකේදී careful වෙන්න ඕනද කොහෙදද composite entities එන්නේ relationships වල තියෙන attributes කොහමද? මොකද scenario එකක් දෙද්දී අපි දන්නේ නැහැ. හරි? ඒක read කරද්දී අපිට click වෙලා තියෙන්න ඕනේ. ඒක click වෙන්න නම් අපිට මේ තියෙන basic concepts ගැන හරි idea එකක් තියෙන්න ඕන. එතකොට මේ relational schema එක ගැන තමයි exam එකේදී ER diagram එකක් අහනවා කිව්වා relational schema එකක් අහනවා කිව්වා. හරි relational schema වල මේ final format එක අඳින්න ඕන එක මෙහෙම කියලා නෙමෙයි කියන්නේ. හැබැයි මේ මෙතනින් ඔයාලට relational schema එක කොහොමද කියලා basic idea එකක් ගන්න පුළුවන්. Okay, next one is regarding to relation database model part 2, right? So basic modeling concepts, conceptual models. Previously we mentioned that why we are using relational schema. We mentioned one advantage. What is that? Conceptual simplicity. Here this model is simple one. That's why this is a very famous in between industries. Okay, in present days, relational these databases are used in these types of relational database model is used in different databases. Another thing is object-oriented model that is also using. But okay, then so very complex level database model we are using double OP concepts, and here it is okay to use relational database model and concepts of model. Conceptual in schema. Again, we can describe this concept using by using an example. Conceptual model, also called as conceptual schema. New terms are coming here, right? You have to adapt it. We have given introduction to relational schema. So how relationships are built and how, why, oh, that kind of things. Then look at this example. University is there, student there again, professor, course, class and room there. Entities can be found there. You all know what are the factors you have to consider while you are choosing an entities. And for one entity, student entity, normally these things can be attributes. How these attributes can be selected according to the case or the scenario that is given in exam or some practical related issue, right? And here we have selected these things have been as the attributes. Then given entity shown, we can define describe relationships among those entities from lesson 10. Okay, same thing are repeating here. And conceptual schema is used to relate one entity to another. So conceptual schema, this is also we can familiar with these notations and mentioning of these relationships. Okay, and then here in class and professor, one to many relationship, right? So one professor can teach multiple classes. So one class only has what? Only one professor. Then here, this example. So that scenario, so one by one has been described here, right? Professor may teach, many classes, but a class is taught by only one professor, right? Yes. So like kind that way, then no need to read this and looking at these things, you can understand it. So course may generate many classes, but each class references single course that there is one-to-many relationship between course and class. Okay, read these things. Then we can analyze the scenario. Okay. So read these things. So conceptual schema, hope you can understand the definition. Okay, then it is not a new thing, just the word, just only the word is the new. And you already can understand what is conceptual model. So independencies, hope you know, you learned about different types of independencies. Data independencies, structural independencies, and here we are talking about software and hardware independencies. For internal model, so another theory related thing, right? So internal model. Internal model requires designer to match the conceptual model characteristics. So a lot of theory is there. Just read these things. After that, we can go through that internal model concepts. So internal model characteristics can be changed, altered according to the requirements of the database management system. We already know that. So what does it mean by database management system? Basic thing again, huh? Management system means normally we felt that database management system a software or hardware related thing. Definitely software, right? No hardware, right? Database management system means that is talking about what? Software. So different softwares can be used for manage databases, right? So internal model by creating a database XYZ, university using the tables, professor these things, the same kind of things. Then previously, so what is the different thing? So this is the way actually you have to map ER diagram to, and you can see here there is no many to many relationships, and composite entities can be found there, and the way that one relationship type can be marked there. So internal model, division of an internal model in external models that are represented by external schemas. Here, look at that. Okay, I told that DBMS means what? Software related things. Still hardware independent because it is unaffected by a choice of computer because of so software like operating systems would not be affected. Storage devices not be effects for this internal model. So external model based on the internal model is the end user's view of data environment. Previously mentioned internal one, but here once a specific DBMS has selected, the internal model adapts the conceptual model of it. Specific DBMS has been selected. That is related to a designer. You know what is mean by implementation? Already included in the course name too. And here, external model. Again, that according to that, compare with the internal model, right? Internal model, we discussed about designers view kind of thing, designers software, DBMS software. Here, external model. So users, end users, it is focusing on. Okay, go through these things. These are the facts you have to be careful when you are going through external model. Little bit in detailed way you can see these things. External schemas can be displayed as this way. So this is another example. External model, same example actually. External models you can used for represent X, Y, Z university. Can see here entities can be have been separated for that externally. Then external means they have been separated here, but class professor room in a one section, and other one student related scenario. Class enrolled student can be displayed as this way, and this internal external related models. These external internal models are using why due to advantages. So these are the advantages. You can go through these things, then you can understand the advantages of these kind of models. Easier to identify specific data. Then external model also make designer job easier. So providing feedback about conceptual model and adequacy. And that kind of advantages are there. Security constraints. Another model. So before discuss this next model, physical model. Okay. Again, understand this concept properly. Then finally, physical model. Physical model operates the lowest level of abstraction. Physical model requires definition for both physical storage and hardware related things, right? Both software and hardware dependent. Mainly hardware. Dependent on the database. So it would not be produce more benefits when compared with the previous conceptual models, right? Previously discussed these kind of models. So software, hardware, independent models are considered as comparatively more beneficial than others. Okay, these models related things are needed to understand. And the main picture you should get same like these things, right? The way of drawing ER diagrams, that is the main goal. By understanding required theories, concepts, it should be the final goal. The next one is relational schema, right? When you know these things, then drawing or mapping relational schema is simple. So these things would be help you to score more than 50 marks ER related scenarios. Okay, then as from SQL, you can score again around 50 marks. So that's the way you can score at the final exams. Then these next two presentations about regarding to developing ER diagram part 1 and developing ER diagram part 2. Right? Yeah, actually, you have to handle the learn things properly and okay, just find a question. Now you can find questions from your past papers and now you can what? Try to write answers for the given scenarios. Given scenarios may be longer than the things we studied, but the things, the basic concepts, basic theories we used to learn can be used for right answers properly and accurately. So we have to discuss these things, right? So these optional scenarios, kind of things. So while you are drawing, while you are mapping ER diagram, you have to follow. But then there are no new things at this in these sections, right? Professor, chairs, department, maybe optional. That means what? Yeah. So who optional, professor or department? Now you know who is the optional one, right? And what is the maximum one or minimum one should be there. So, okay, while looking at these diagrams, figures, you should be clearly get an idea about what is 1, what is 0, what is optional, what is non-optional, what is strong, what is weak, what is mandatory, right? What is not mandatory? Not mandatory means optional. So then that kind of things should be able to understand properly and make decisions properly and finally design the output. So this kind of level is expecting at the exam. Got that? So scenario finally, this kind of result would be able to draw at the exam. So previously mentioned that ER diagram related theories you can score marks more than 50, but while after drawing this kind of mapping this kind of thing at the final exam, you can score more than 30 marks out of 100 just from this kind of design or answer related accurate one, right? And okay, then now you know theories. You know that theories are not enough. Okay, then performing is must. Do activities and try to draw things. There are so many online tools also to draw these things. But okay, at this level, just find questions with answers and understand relationships and try to start from the beginning and draw one by one and go do the complexities questions according to the what complexity of the given scenarios. So they are the things. Okay, here finally, this is the thing actually we have to discuss in the next lesson. What is that? Previously mentioned relational schema and how relational schema can be exactly. So we already now have some idea about these things, but how you can properly build that with required information accurately. So they are the things and how these things can handle we can discuss these things in next week, right? Or next week, next session, right? Maybe scheduled to be, it has been scheduled on 22nd on November. Okay, that's all for today. We are going to end the meeting for today.